My name is Andrew Betts. I work for Fastly. I'm a developer relations engineer, and I'm also kind of obsessed with the web platform. I used to be on the W3C's technical architecture group, which is a group of 9 people that looks after the architecture of the World Wide Web. And so in that role, I saw a lot of the new standards which are coming to the web platform, things that will help to make it bigger and better and capable of doing more things. What's interesting about feature policy is that it helps us do less things. And that makes it kind of unique in terms of new stuff that we're inventing on the platform. So why would we want to invent a new technology to make the web smaller? And to answer that question, I think we have to recognize how old the web is, and that over time, some things are a bad idea. And that when you do things that are a bad idea, you need to be able to move on from them, even though you might have built stuff on top of that bad idea, so it's quite difficult to back out of now. One example in my own life recently is I'm trying to buy a new apartment, and there's a part on the back of the apartment which isn't on the plan, so it's possible that I might have to demolish that part because it wasn't an approved addition. Unfortunately, the person living on the floor above me has already built an extension on top of that area of the apartment. So if I take my part away, then his apartment will collapse. So this is a good example of building in bad practices into a platform and then being unable to move on from them. So how do we apply this to the web? Well, and how does feature policy become the solution to this? Well, for those of us in the room who are capable, if you cast your mind back to the year 2000 and try and remember what the web was like, to help you, I will tell you that the most popular phone at the time was the amazing Nokia 3310. I had one of these for a long time. I used to go on holiday and not bother to take the charger. It was amazing. So what was the web like in 2000, and more specifically, what was the most popular JavaScript API? Now, I don't have any data on this. I don't have a web page test, or HTTP archive didn't exist back in 2000, but I can be pretty sure I know what the most popular JavaScript API was. I think it was this. And the reason is because I remember the web in 2000, and it looked like this. And this was pretty bad. But the web doesn't look like this anymore. So this was a crisis, and we managed to move on from it and solve it. Mostly by preventing access to this API. Initially, developers built browser extensions, and then implementers actually baked that functionality into the browser itself. So you now can't use this API unless it's triggered by an actual user interaction. So this gives us an interesting insight into the way that the incentives and motives of different parties to the web platform play against one another. So we have developers, that's us, browser vendors who make the user agents, and major websites, places where we start our journeys online, places like Google, Facebook, and Twitter. And all of these people have different motivations for creating interventions to help the web move forward. To me, this feels a little bit like more mature ecosystems like flying. I just flew here from Japan, and I did so without crashing into any other planes, despite the fact there were lots of planes in the sky at the time. I think that's kind of amazing, and this happens without any one authority being in global central control of the process. But this is a very mature ecosystem, and compared to this, we are really taking baby steps. So let's think about the next crisis that happened on the web and how we dealt with that. So the year is now 2007, and the Apple iPhone is the most popular phone at the moment, which had the world's first really usable mobile web browser, although you could only use it on Wi-Fi because it had no mobile data. So the web is now great. We don't have any pop-up windows. The user experience is awesome. Well, not so much. Everyone's using Flash to display their adverts, and so it's quite common for Flash to be consuming 3 to 4 times the memory footprint of the browser itself, and obviously opening up your system to myriad security vulnerabilities and so on. And Apple had this problem that they really couldn't support this third-party plugin on a platform like the iPhone. So they just decided not to. And this is the open letter that Steve Jobs wrote on the Apple website at the time, saying, we really love Flash, but not really. And so that was the end of Flash. I mean, I'm speeding things up a little bit here, but over the next few years, a whole industry of people basically retooled and started building ads using different technologies. But this was a great opportunity for things like HTML Canvas to really come to the fore, and SVG as solutions to the problems that Flash was traditionally used for. And these technologies had already been invented by this point, but the adoption was not there because we knew how to use Flash, we had a whole industry that was trained to use it, so it really required this intervention to push us forward. 2015. So now we don't have Flash anymore. So the web is great and the user experience is fantastic and we don't have any more problems. Except we do. The phone at the moment is now the Samsung Galaxy S7. So compared to the iPhone, this one actually has multiple web browsers that are independently installable and updatable. It also has an astonishing amount of computing power. But we're trying to use it as much as we can. So over that period of time, the average web page would increase in size by about 250%. In the latter couple of years, that increase was driven almost entirely by video. And so now we're finding that the web is still a pretty lousy experience on mobile, but not because we don't have the power. We have the power, we're just abusing it. So the intervention here comes from the major web platforms, people like Google and Facebook and Apple. They don't want to link out from their ecosystem to a piece of content that would be a bad experience for the user. Google's response to this is AMP, Accelerated Mobile Pages. Other providers have their own ones, so Facebook Instant Articles and Apple News. And these are all not the web. They are subsets of the web. In some cases, they are intersections with the web that have actually created entirely new features that don't feature in the web platform itself. There's an argument that these create walled gardens, especially things like AMP, where when you click on a result, you actually don't leave Google, you stay on the Google result page and the content is displayed within that environment. I particularly don't like this. I wrote a letter about it, which 700 people signed, and we tried to ask Google to reconsider this. They did subsequently change the governance model for the AMP project to be a more open and collaborative one. But as of now, I think there's still some concerns about this project. The thing is, this isn't long enough ago that we can definitively say that this was a good intervention that has helped us to move the web forward. But this is something that we're still kind of actively grappling with. So, 2019, what crisis do we face today on the web, and how might we stage an intervention to solve it? Well, this is the latest phone. I mean, I think we've gone a bit over the top at this point. Like, maybe we don't need to invent phones that fold in half, but fine. I mean, I happily buy one. I think it looks amazing. This news site wrote an article in 2018 about Mozilla's plans for that year. And their plans involved trying to tackle bad behaviors on the web. Things like bad ads, sites that autoplay video on page load, and also sites that will automatically prompt for permission to display notifications without prompting, without kind of the user indicating that they're interested in that. And this site displayed this on a my build effects have gone. But they did this on a site that has autoplaying video, bad ads, and prompts for notifications on page load. So I think we can say we still need the web to be better. So despite all of these interventions that have happened in the past, we can look back on some of them, like blocking pop-up windows and getting rid of third-party plugins. And I think most people will look at those interventions and think pretty objectively they were good things. More recent things like AMP, I think the jury is still out on those kinds of things. But we still need to come up with the next intervention that will help us to evolve the platform. So the things that we need are something that allows us to understand what good practice is, allow it to be declared, recognized, and rewarded, and also enforced. Protect the openness and decentralization of the web. And we spend a lot of time celebrating the first of those words, and we don't really do a lot to try and protect the second one. We need to do it collaboratively, and this is the really key point that a lot of standards groups spend hours and hours in meetings trying to get their heads around, that that website you built in GeoCities in 1999 still needs to work. So the whole point of anything we add to the web platform is that it's backwards compatible. So, feature policy. Feature policy is an HTTP header. It's also an attribute called allow, which you can put on any iframe element. It is developer controlled, and it's a statement of conformance that a browser can enforce. In fact, you're inviting the browser to enforce it. It's rather like a doc type in a way. You're stating ahead of time your intention to conform to a certain standard, only this is very granular, much more granular than anything we've ever seen before. And because this is the first time that we've really actively baked developer best practice into the web platform itself, it's really important that as many developers as possible take a look at it, get their eyes on it, and check that the lines are being drawn in the right place. So this is an HTTP request. This is a very simplified one. So, you know, 1997 era HTTP. Today, this HTTP request would look more like this, because we've started to put a lot more metadata into HTTP to do all sorts of things related to security, performance, privacy, a whole variety of different things. Now you can see I've added a feature policy header here as well. You might also be familiar with things like strict transport security, content security policy, client hints. These are all new things that have appeared within HTTP in the last few years. So feature policy, let's focus on this one. Feature policy is a list of tokens. So a token here as an example is document write, autoplay, speaker, and unsliced media. And for each token, we then have a list of origins. So this origin list can either be an explicit origin, like badthirdparty.example.com, or it can be the keywords none, self, or star. So what we're saying with this feature policy is that we are going to deny ourselves access to the document.write API. No origin is going to be allowed to use that API. So that includes the host page that sets the policy, and also any iframes that are included within the page that load content from a third party will also be subject to that restriction. Likewise, within the same scope, we're also banning autoplay, so we can't autoplay videos. Any video element that has an autoplay attribute on will be treated as if it's an attribute that is unknown. The browser will just ignore it. The page itself is allowed to emit sound, but any iframes we include on the page from a third party are not allowed to emit sound. And here, unsized media is an example of a kind of hopeful deprecation, where we've identified a kind of behavior that we don't like. We can write an accurate definition of it, and then we can associate a token with it. And I'm going to show you what that means right now, because it's time for a highly unwise live demo. So I have built a website to demonstrate all of these things called featurepolicy.info. I have to have DevTools open while I'm demoing this for reasons. So the first one I want to show you is one of the categories of feature policy that is guarding a so-called powerful feature. So the web platform is now adding more and more of these, things like USB or access to Bluetooth, things that we really don't use on most of the websites that we create. So let's look at camera, for example. So normally, when a website wants to use the camera, it will call the appropriate media capture API, and then the browser, if it doesn't already have a consent recorded for that user interacting with that domain, for that resource, it will ask. It will pop up a native dialog saying, do you want to allow example.com to use the camera? Now, I've already done that previously, so this just works straight away. Feature policy adds another layer on top of that. So if I add this feature policy camera none, can everyone see that, or shall I make it bigger? Let's make it a bit bigger. Okay. So if I were to set a feature policy of camera none, which I will now do by toggling the switch, the camera no longer works, and instead I would get a JavaScript error, not allowed error, permission denied. So this is exactly the same error that you would get if the user had clicked deny on the interactive consent prompt. So it's exactly the same kind of result, but with no interaction. The user was never prompted for anything. So this is a really nice thing to do if you have a bunch of third parties on your page and you really don't want random advertisers trying to access the camera. You can just turn it off. So I now do this on all the sites that I build. So that's a category of feature policy that we can now apply to all such features. So you'll see that there are ones for things like geolocation, USB, serial, microphone, anything that reaches outside of the browser sandbox should now have a feature policy guarding it as well. So that leaves us with this second category of feature policies that I think are more interesting, which is the hopeful deprecations, the bad practices that we're now going to bake into the platform. So let's start by looking at one called font display late swap. Now, if I refresh this page, because you may not have seen it the first time, we see some text rendered using a very artistic web font, and that font took a while to load. So what happened was we got the HTML, so we know what the text is almost immediately, but we don't render it because the CSS here says font display block. Now, a font display block rule says don't display this text until you have the font face that you need to render it correctly. Now, that's generally speaking a bad practice, because if you don't have the font by the time that the text is available, then you're basically denying the user the ability to read the content, which they could otherwise be quite happily reading. And I find this particularly annoying if I'm on the tube in London and I have a dodgy signal, and I know that I've got the article, but I can't read it because the font hasn't loaded yet. And sometimes, you lose the Wi-Fi before the font loads, and now you're holding a device that you know has within it the text that you want to read, but you have to wait 10 minutes to find out what the text says. That's stupid. So if we disallow that behavior by taking font display late swap, which is the phrase we're using to describe this kind of practice of late swapping of web fonts, and we disallow it, okay, so now the text renders almost instantly, but in a fallback font. So by disallowing ourselves this behavior, what we're now forcing ourselves to do is, if we want our text to reliably render in the right font, then we have to make sure the font loads before the text does. Okay, let's look at something else, like this is one of my favorite ones, layout animations, because it has a fancy demo. So for quite a long time now, we've had the ability to create efficient animations on the web. Things like CSS transitions and CSS animations. They are hardware accelerated. They are capable of being moved to a different render layer. They are an efficient way to use the browser's rendering engine. This animation is not one of those. This animation is being created by continuously repositioning this div's left property, which means we can't use any of those optimizations that browsers now have for CSS animations and transitions. So if we disallow so-called layout animations, these are animations that cause the browser to recalculate layout on every frame, then we're not allowed to do it anymore. So the browser will simply render the start and end state of the animation without rendering any of the intervening frames. It will put enough work into it to calculate what the beginning and end state are, but it then won't do the work to recalculate the layout every time. Another easy, quick win if you're looking for better rendering performance, especially if you have a single page app, yes?
So how does this work? How does it block the animation?
How does it block the animation? Well, the user agent will just switch to a different rendering mode for the animation.
But this uses a timer, right? If that sounds correctly, so it actually 200 milliseconds and recalculates the position.
Well, so the animation is defined, and so let me go back to it here. So in my code here, I am actually using a CSS animation definition, but the property I'm animating is one that can't be accelerated. So the browser is able to use this definition of the animation to determine where the beginning and end states of the animation are and how long the animation takes to run. So rather than animating as I've asked it to, it's going to replace it with a different animation that has only 2 frames and has a much longer duration between the frames. And that enables the browser to avoid doing recalculations of layout and compositing for each frame. One more I'll show you before I switch back to the slides is unsized media, which is the one I mentioned earlier on. So those of us who've been coding on the web for long enough may remember writing image tags with no width and height attribute. It was great. Like, the browser would figure out how big the image was by downloading it, and then it would just pop it into the page at the right size. And we wouldn't need to worry about putting explicit dimensions on the images. But now we know that that's a pretty bad idea, because if we have to sniff the dimensions from the image data itself, then the browser will have to repaint the layout several times, because it will initially render the image at 0 size or at a standard size, and then it will re-render it at the correct size once it knows how big that image is. And that's what leads us to effects like kind of juddery rendering of pages that contain a lot of images. So here you can see I've got an image tag. It has no width and height attribute, but the image itself is 150 by 300, which is being correctly rendered here. If I disallow unsized media, then every single image that is loaded will be 300 by 150. So essentially the inverse of the dimensions that are actually the natural dimensions of this image. The reason for 300 by 150 being baked into the spec itself, which seems really weird, is that 300 by 150 was the default size of iframes back in the day. So if you create an iframe, you don't give it an explicit size, 300 by 150, that's now also the default size of an image that is subject to the unsized media policy. So let's switch back to the slides. Okay, so I think we get the idea of what feature policy does. So what would happen if we took all of the policies that apply to bad practices or supposed bad practices, we put them all into one feature policy and we disallow all of them, and then we start browsing the web? Well, I tried this. I can tell you it's a very fast experience and almost nothing works. To be fair, I should start with our own website, fastly.com. It's not great, to be honest. And the most obvious thing that jumps out is that the font is wrong, and the logo isn't displaying. And also, if you were able to interact with this, then the menu in the top right isn't working either. So there's a few things going wrong here. The first one is that the sync script policy is disallowing any script load that is blocking the rendering. So we have a few scripts that we're loading synchronously. They are being loaded at the very bottom of the document, which used to be considered a best practice. Not anymore, not according to feature policy. So unless it has an async or a defer attribute on it, it's still blocked by the sync script policy. We then get a bunch of JavaScript errors that are being triggered because we didn't load those synchronous scripts, and we have a bunch of asynchronous scripts that are expecting those synchronous scripts to be there, which is creates all kinds of chaos. We can also see some unoptimized images here. So there's supposed to be an image here. This isn't loading because it's considered to be not compressed enough. Unsized media, few instances of that, and oversized images as well. Oversized images is really interesting. That's the one that applies to our logo here. That's why the logo isn't displaying. The reason for that is that we have a fluidly responsive website. So as you make the viewport bigger, the logo will gradually get bigger to make it itself a sensible size for your viewport. But we don't have a logo in every single possible size. We just use the same logo, and it's often not quite the same size as the frame. Feature policy says, can't do that anymore. The image has to be the same size as the frame, to within a tolerance. But that tolerance is too strict for what we're trying to do here. So that's the Fastly website. We also have some very nice customers who let me trash their websites and then publish the results, which is very nice of them. This is Le Monde. They have very similar story to Fastly.com. So synchronous script execution. Incidentally, if you see the synchronous script execution as the first thing that gets blocked, that's going to be the thing that has the biggest impact, because then all your buttons and your menus and everything that is like a fancy additional feature of the site isn't going to work. We also see a bunch of image stuff, like similar to what we had with the Fastly site. You can see that's the reason why these thumbnails are not displaying. And also, Le Monde has layout animations issues. And this is preventing the site from sliding down to reveal an advert. Some would consider that a good thing. Next, Nikkei, where I used to work. So I'm slightly embarrassed about this, but they have some very, very unoptimized thumbnails going on the homepage. So the main issue with this site is that feature policy considers 26 kilobytes to be too large for an image of that size. So if you disallow unoptimized images, then this image will not display. So I picked on a couple of publishers here, big publishers with big advanced development teams, because it's worth stressing that the web platform is not something we can change quickly, and also big enterprisey websites are not architectures that we can change quickly. These are advanced development teams. They go to these kind of meetups, they go to conferences, they are striving for best practice, but they can't move the tanker, they can't steer the tanker quickly enough to always be on the cutting edge of best practice. But some sites are. So I had a look at WebCore. What is it? WebCore.group? Just before the talk, I loaded up the site for this meetup group, which is a very simple website, and looked at what the feature policy result was there. So it's not bad at all. 2 violations, 1 unsized media and 1 oversized images. So oversized images applies to this, unsized media applies to this. And this is a pretty common problem. Hi, go ahead. Yeah.
What are we supposed to do about violations like oversized or too small images? As you said, with your logo on your website being sometimes too small, sometimes too big, how can we control something like that?
So in some cases, there would be ways that you can just adjust your practice to avoid those patterns. In some cases, you might argue that you need to do that, and therefore you need to get involved in the spec and change that rule. Which is the reason I'm giving this talk, by the way, because most of the people involved in feature policy are not developers. So they just decided that this was a good idea. But this might be the section you're interested in as well. How do we debug this? So what if the developer of that site, or any site that is deploying feature policy, is using a browser that doesn't support feature policy when they're doing development, or is using a browser that has different cutoffs, different thresholds for what it considers reasonable? You might find that the site is working for you, but maybe it doesn't work for a different browser that's being used by a user somewhere else in the world that has the threshold set in a different place. So the reporting API is another new feature of the web platform that is designed to help us to understand and get our heads around this. It is a generic mechanism for reporting events, interesting events, from browsers to your server. You can actually interact with it in multiple ways. This is the JavaScript API, which I think arguably is less useful, because if your problem is that your JavaScript is not loading, then having a JavaScript API to interact with those messages isn't going to work. But if you want to deal with the reports in JavaScript, you set up a new reporting observer, hand it a report handler and a configuration. The configuration is saying these are the kinds of reports we're interested in. Buffered true means we want to know about things that happened before we started observing. And then this function is the callback we want to call when some report is generated. More usefully, though, is probably the HTTP version. So you can set an HTTP response header report to. You give it an HTTP URL where the browser should send violation reports to. This is probably the first header that I've ever encountered that has a JSON format. The argument for this is that it is quite structured data. Like, you can have multiple groups, you can have multiple endpoints per group, each endpoint can have multiple properties. I still think it's a shame that they went down that route, because it really does not look anything like any other HTTP header. But the nice thing about this is that even if nothing else works on your website, you can still receive beacon reports to a collection endpoint. Yes?
Can you configure the header to only send sort of a warning to your report to a URL instead of actually blocking it?
Yes. So that's not part of the reporting observer standard. That's part of the individual specs that use it. So in the case of content security policy, for example, which can use reporting observer, there's a content security policy report only mode. And also in the case of feature policy, there's a feature policy report only header. So you can set that, and then it just does the reports. It doesn't enforce anything. So, in conclusion, feature policy will be a thing that will start to become relevant to you. If not for your own internal standards, it might well become a thing in terms of getting an app to appear in a promoted slot, or maybe in top stories on a Google search result page, or maybe in a kind of app store might require you to have certain feature policies in place. All kinds of integrations with third parties might start to require feature policies to be met. So to be prepared for that, all the usual things, all the best practices that we've been talking about for several years are now starting to become enforceable by the browser. And most importantly, take a look at these policies. Go to featurepolicy.info. Try out all the tests. I've written a test for every single feature policy that Chrome has shipped. Take a look at them, see if you think they're reasonable. If you don't think they're reasonable, then go and get involved. And let me know if I can help. Thank you.
Thank you, Andrew. So we're a little bit ahead of time, so let's do one question if you have some.
Any other questions?
And then, yeah, so
Yep.
you were first.
It seems that some of these feature policies are on the wrong side of the browser. That as a user, I want to be able to set these policies. And unscrupulous websites aren't going to say, don't let me ask for camera access. But as a user, I would like to be able to prohibit that. Is there a plan to expose these the same way that we blocked ad pop-ups at the user agent?
Right. So, if we go back to something like never slow mode, you can definitely imagine, I'm not speaking for any browser vendors here, but you can definitely imagine that something like this might end up powering some sort of make it fast button. So, if a browser detects that a site is rendering slowly, it's using a lot of CPU, it might say, there are layout-inducing animations on this page, probably choose some better words than that. Do you want to stop them? And then you would push a button and it would apply a feature policy to the page. So I definitely think that that's on the cards. If not from the implementers, then extension developers. So yes, you'll for sure be able to download an extension that will make all your browsing experience fast, but will break quite a lot of the web in the process.
But no one's going to enable these policies on their own website, right? Like with XHTML, where if you make a mistake in your HTML generating code, then the whole website doesn't render anymore. No one wants that. No one wants to make their own website.
Right. So I think
unless you're doing it for Google optimization, I guess that's the only.
Right. So yeah. So part of the incentive, I think, will be pushed to you by web platforms that want the web to be faster because of their own commercial incentives. Part of it will be your own internal process.
Yeah,
I've been a member of many large development teams where there's a PR review process that will be checking for some of this stuff. Like, we won't let a document.write ship to production, but we don't need to worry about that if we've just technically disabled it. That saves a lot of money. So there might be a whole bunch of those kinds of things that might help to ensure compliance, basically. That's why you would want to impose them on yourself. The other and the most important use case in my mind is the third-party one. So if any of us here are building third-party scripts, something like a Discuss or an ad or tracker script or something like that, then this is going to complicate your life. I'm not going to say this is bad news because I think it's generally good news for the web platform. But it will complicate your life because you will find your script is being embedded on sites with a wide variety of different feature policies, and you will need to be able to comply with all of them. The lowest common denominator, basically, which will be if all features are disallowed. How do you deal with that? Good.
For example, you were explaining that this header is sent by the server. So the server sends the header, but okay, if it's a React application, it's the application inside the browser. I would like to have something to limit, like, my app only wants to work with camera and push notifications, but nothing else. So no one else would be able to break the layout, my application. This is the only use case that I see right now. So third parties that are embedded in my glorious website will not be breaking my glorious website by adding more and more pop-ups and
yeah, or doing top navigation, for example. With iframes, we mostly believe embedded iframes will not attempt to navigate the top document, but they could do anytime they want to. We can prevent that with a feature policy.